Very good morning to all of you. I hope you all are safe and healthy. In last session, we already discussed about what? Discussed about measurement of length and methods, right? And what are the methods to measure small distances and large distances? Such classification we already discussed in last session. Clear? Right. So, any physical quantity can be measured directly or indirectly. Right? Some methods are direct methods, some methods are indirect methods to measure any physical quantity. So, yesterday we already discussed about measurement of length. Length can be measured in two ways. One is a direct method, one is indirect method. Give some examples for direct method. By using meter scale, by using vernier calipers, by using screw gauge. If you find out any length, if you measure any length, that is nothing but a direct method only. Sir, when we prefer indirect method, for example, to find the distance between Earth and Sun, to find the distance between Earth and star, meter scale, vernier calipers, tape scale, it's not a convenient instrument to measure such large distances. Under that situation, one can always prefer indirect method. That indirect method is known as parallax method. Parallax method. Okay? So it is a indirect method but not a direct method. Indirect method. Clear? Right. So what is direct method? Already we discussed, like with some help of instruments like meter scale, screw gauge, vernier calipers, right? One can measure the length for a given object. Then that is direct. Then what is mean by parallax method? To understand, for better understanding of this parallax method, now I will give one best example. Clear? Now, what is mean by parallax method? Let us consider any object, pen or pencil. Okay? Keep this object in front of your eyes, against to some background. Listen carefully. Now for me, this is my background. Okay? Now I am holding this chalk piece like this against to this background in front of my eyes. Clear? Clear? Right. Now, next. Hold your pen like this, right? And which should be placed in front of your eyes against to some background. Right? Then close your right eye. Hold your pen like this, close your right eye. And observe the object position against to background. Then after that, close your left eye. Observe the same object against the background. Did you find any difference? Did you find, sir, we feel blurriness? Hey, I'm not talking about your eyes, blurriness. Just did you find any difference between the position of an object against the background by closing one of your eyes? Yes, sir. Yes. Correct. Once again I am repeating, listen carefully. If you keep an object like this in front of your eyes against to a certain background, let us assume this is background, okay, fine, it is background, right? Now I am placing an object like this, okay, then when you are keeping this object in front of your eyes, first you can close left eye or right eye, any eye, first you will close it, then observe this object only with one eye against to this background. Then, for example, you are observing with the left eye by closing right eye. That is over. Then next, observe with the right eye by closing with the left eye. Did you find any difference in position of the object with respect to background? Yes. So that method is known as parallax method. So when we observe this object against to background by closing one of your eye, we feel that there is a apparent change in a position of an object with respect to background is known as parallax. Is it clear? Apparent means not real. So by closing one of your eye and observing the object with respect to background, it seems to be that object position seems to be changing, appears to be changing with respect to background by closing one of your eye. Such a method is known as parallax method. Okay, right? Doing this experiment when you are watching this video, just you will do this experiment, then you will come to know there is a change in position or not. By closing your eye, for your eyes, it appears to be, it seems to be changing position of an object such as pencil or chalk piece or pen with respect to background. That method is nothing but parallax. Okay? Now here I will write definition. The apparent change, the apparent shift or change, the apparent change in position of an object with respect to background, with respect to background is called parallax. Okay? Right. Very simple. Right. Then actually why you are using this parallax method? To measure large distances such as distance between Earth and Sun. Sir, how to find the distance between Earth and Sun? Right? Okay, listen carefully. Two persons are in two different places. Two persons are in two different locations and observing the sun. Clear? Right. Now, diagrammatically I will explain. See. Our planet, let us consider planet, any one planet. Right? Okay, fine. Right? Planet or sun. Then consider two persons. Let us assume this is Earth's surface. Two persons A and B are in different places. Okay, see. Now I am observing the sun like this. Okay, person A. Person B observing the same source, same object in a different location. That is A and B. But both are observing the same planet. Right? Both are observing the same planet. Here, person A observing this planet in which view, in which direction of angle? In this direction. Okay? He is observing like this. Okay. Similarly, B person, the view, the directional view of person B. Directional view of person B is this. Directional view of person A is like this. Then this is what actually the distance between the two persons are two positions on Earth's surface. Right? Okay. Now here I will represent with some notations. This is B, it is D, it is also D. Okay? So if you observe this planet from this location, the distance between A and B is D. And similarly, from same Earth surface, from different place, in different locations, you are observing the same planet, right? Then this distance also equal to D. Clear? Right. Sir, what is B? What is D? Okay, here I will write. Listen. B nothing but basis. What is meant by basis? The distance between A and B is known as basis. Right? Next, what is D? What is D? D is the distance of planet. Distance of planet from where? From A and B. From A and B. Clear? Right. Then next. Sir? See, this is what view of direction with respect to A. This is what view of direction with respect to B. Then the angle between right, the two directions in which they are observing the planet is known as parallax angle. Clear? Right. Now that one here I will represent with the theta. This is theta. What is theta? Theta is nothing but parallax angle. Theta is parallax angle. What is parallax angle? It is the angle between the two directions in which the two observers observing the planet is nothing but parallax angle. I hope it is clear. Okay? Right. Then, what is our aim of this method? Our aim is to find dr, br. Capital D or br? Capital D. Capital D. I want to calculate the large distances between Earth and Sun, or between Earth and planet, or between Earth and star. Now I want to find D. Sir, how to find D? How to find D? Listen carefully. Sir, if this theta is very small, if this theta is very small, what happened, you know? This is straight line AB. For your eyes, this AB line straight line or curved line? Just observe. AB is a straight line only. Right? If theta is very small, then this AB becomes an arc of a circle. Then that AB is taken as the length of an arc of a circle. So if theta is very small, AB considered as an arc of a circle. Now we can easily to find capital D by using plane angle formula. Am I right? Yes, absolutely. Okay? If, see here I wrote, if again wrote us, sir, here theta is not small, sir, it is not a straight line, sir. Why you are considered arc, sir? Ray condition. If this theta is small, then this AB acts like, AB becomes length of an arc of a circle. So, if you consider AB as a length of an arc of a circle, right? Then, now we can easily to find. This is how much? B. This is theta. This is D. What is theta actually? Plane angle formula, length of an arc divided by radius. Now this B becomes radius of the circle. Now this P becomes center of the circle. So theta is equal to length of an arc divided by radius. Length of an arc divided by radius. Now theta is equal to, what is the length of an arc? B. What is the radius? D. Okay? Right? What do you want? What do you want? We want D only. Then D is equal to B upon theta. So this is the way to find the distance between, average distance between Earth and planet, Earth and Sun by using parallax method. So please put this formula inside a box. Okay, I hope it is clear. So this is what the way of approaching to find the largest distances with the help of indirect method, that is parallax method. So next one is by using parallax method, one can not only find the large distance between Earth and a planet, one can also find the angular size or diameter of any planet. How? So next one is diameter of a planet. Listen, you know very well all planets are, we are assuming in a spherical in shape. Alright? Okay, let us assume it is in our imaginary planet. Right? For this, you just consider two diametrical points. Two diametrical points, A and B. Okay? Now, you are observing these two diametrical points from surface of Earth. Or I want to calculate angular diameter of Sun. Okay? Then you have to consider two opposite diametrical points and observe these two opposite diametrical points from this position. Okay? So let us assume it is like some C. Right? Okay. Then the person who is standing at this position and observing this diametrical point in this direction. In this direction. Similarly, the same person is observing this diametrical point in this direction. Okay? Right? Wait 1 second. In this direction. Clear? Right. You know very well. The angle between the two directions in which we are observing the two diametrical points is known as parallax angle. Parallax angle. And the distance between A and C, the distance between B and C is D only. Okay? And what is the distance between A and B? Actually, it is a diameter. Okay? But this diameter in terms of parallax method, it is known as basis. Basis B. Then it is easy to find value of B. Now what is B? B is the diameter of that planet. Angular size of the planet we are expressing in terms of diameter. Again you have to assume same condition. If theta is very very small, if theta is very very small, right? Then if theta is very very small, then we can write like this. Theta is equal to B, length, this is nothing but length of an arc, divided by radius D. What do you want? We want B. Okay, for our convenience, just I will change this theta because of in last method, in last condition we took this is theta. Now I will change this as alpha. Okay, now alpha is equal to B into D. B is equal to alpha into D. What is B for this sphere? B is nothing but diameter. Am I right? Diameter. planet we are expressing in terms of diameter. Put this formula inside a box. Clear? So this is about finding the larger distance and angular size of a planet by using parallax method. I hope it is clear. Right? So the next. Sir, then how to calculate smaller distances? I told you already in last session. For estimation of smaller distances, such as size of a nucleus, size of an atom, size of proton, size of electron, size of molecule, all such small distances can be measured accurately with more resolution with the help of tunneling microscope. Tunneling microscope. Am I right? So here I don't want to write the formula to find the very small distances. Just I will write like this: size of, to measure small distances, size of an atom or molecule. Size of an atom or molecule is equal to thickness of a film. Thickness of a film. Okay? So according to textbook only we have to follow all these notations and definitions. Right? While I am explaining all these things after completion of this video class, if you have textbooks, just you go through the textbook. Right? In textbook one example is given, one oleic acid mixed with a solution, and they are finding size of the atom, size of the molecule with one example. But we don't want all such calculations. You know already in chemistry how to find that. So thickness of a film, whatever the method they followed, I will tell you. Volume is equal to area into length, or here they consider L as a thickness. Okay? Then this thickness is equal to volume divided by area. That's it. Okay? So apart from this, we don't want more than this. So size of an atom is equal to thickness of a film. If you want any doubt regarding about this, you just refer your textbook. Right? In that textbook one example is given, but that is not at all important even in board point of view. So I don't want to waste our valuable time. Clear? Right. Sir, listen carefully. I will give more explanation where it is most important related to board point of view, CET point of view, NEET point of view. For example, few topics and few definitions are not that much important. Right? So under that condition, I don't want to drag that concept. Clear? So this is enough. Right? So this is what, to estimate smaller distances, we always prefer tunneling microscope. Okay? Right. Then next. Practical units of length. Practical units of length. Sir, practical units ಅಂದರೆ ಸರ್ ಎಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಿ ಸರ್ practical units laboratory ನಲ್ಲಿ ಸರ್ no practical units, it doesn't mean that it is used in practicals. No, not like that. We are not using these units in physics laboratory, not in practicals. I will tell you. From that example, you can easily understand what is meant by practical units. Listen carefully. Sir, to find the length of this wall, shall I use meter scale? Yes, we can. So length of this board we express in terms of meters or centimeters. Yes, correct. Now I want to find the distance between Earth and Sun. Okay, we can find out by using parallax method. But shall I express the distance in terms of meters? terms of meters. If you express the distance in terms of meters, roughly I am writing, it's not exactly, roughly, for example I am writing, let us assume the distance is, if you write in terms of meters, we can write like this. See, every time if these many zeros, if you want to write in physics, it is too complicated. It's waste of your energy, it's waste of your pen ink also. Right? So, that's why, under that situation, we are not using meters. See, I will give one more example. In motion chapter, in every numerical problem, they are always measured the displacement, length and distance. They are given in terms of kilometer only. Is when speed also they will mention in terms of kilometer per hour only. But kilometer is not a SI unit of distance. Hour is not a SI unit of time. Okay? Because of, to measure the distance between Delhi and Hubli, meter is not a convenient unit to represent the large distances. Even we can represent like this, but while writing, we feel somewhat it is bigger value. Then under that situation, we are introducing this practical units. I will give one more example. I want to calculate diameter of orange fruit. Yes, it is possible. I want to calculate diameter of this size marble. Yes, possible. Sir, I want to calculate size of proton, size of neutron, size of nucleus. Then millimeter, centimeter is not a convenient unit to represent that very small value. Under that condition, we are using some special units which are nothing but practical units. Okay? Practical units means we are not using in physics practicals. Practical units are additional units in addition to MKS, CGS, SI. Okay? So when we use these practical units, just now I give example, to find the distance between Earth and the Sun. Meter we can use, but value is very large. Around, if you express the length in the distance in terms of meter, around there are some 15 to 20 digits. Every time it is very difficult to write that 20 digits number. And if you want to find size of nucleus, size of nucleus is 0.00000015 something meter or millimeter. See, after decimal how many zeros we will put. So that's why we are introducing practical units. I hope it is clear. Apart from that, we don't want and don't think behind that. So practical units of length. Practical units of length. What are the practical units of length? The first one is Fermi. 1 Fermi. Hello students. 1 Fermi. Do you remember 1 Fermi? Sir, no sir. Array, multiples, submultiples. Multiples and submultiples prefix. Do you remember the table or column? 1 Fermi is equal to how much? Tell me. 1 Fermi is equal to how much? 1 Fermi is equal to 10 raised to minus 15 meter. So where we use this practical unit to represent or to measure size of a nucleus, size of an atom, is always in the order of 1 Fermi. Next, 1 angstrom. 1 angstrom. Angstrom, name of the scientist only. Angstrom. 1 angstrom. 1 angstrom is equal to 10 raised to minus 8 centimeter. Okay? Correct or not? Yes, correct only. Now I will ask one question. Listen carefully. 1 centi is equal to how much? It's a submultiple factor. 1 centi is equal to 10 raised to minus 1. No. Centi submultiples from bottom. Second one. Centi 10 raised to minus 2. 10 raised to minus 8. Centi andre 10 raised to minus 2. Meter as it is. Sir, what you are doing, sir? Array, I am converting centimeter into meter. Centimeter I am converting into meter, that's it. 1 centi I am writing in the form of prefix. Submultiple prefix. That is 10 raised to minus 2. Okay, mathematicians, great mathematicians. A raised to m into a raised to n is equal to a raised to m plus n. Correct? Minus 8 plus of minus 2. Minus 8 minus 2 minus 10. Then answer 10 raised to minus 10 meter. Sir, please remember these conversions. Okay, sir, still we don't know, sir, we don't know how to convert, sir. Wait, don't worry, I will explain. Mayuna? Right. So 1 angstrom is equal to 10 raised to minus 10 meter. Clear? Then next, listen carefully. Another unit is astronomical unit. Astronomical unit. Astronomical unit. Sir, astronomical unit means this word related to maybe distances related to planets and earth, like sun, like star. Yes, correct, absolutely. So astronomical unit, generally we use this unit to represent large distances between earth and sun. Then the definition of one astronomical unit is, it is the average distance between earth and sun. Average distance between earth and sun. Okay, so the average distance between the earth and the sun is approximately equal to one astronomical unit. Remember, this is very, very important, these conversions. Average distance between earth and the sun is always 1 astronomical unit. So then 1 astronomical unit is equal to how much? 1 astronomical unit equals to 1.496 into 10 raised to 11 meters. 1.496 into 10 raised to 11. See? No, I will tell you. If you write in terms of meters, how many zeros can you put after 11 zeros. But instead of writing all these numerical digits, if you say only 1 astronomical unit, yes, that is well and good. We can easy to pronounce, we can easy to write the distance between earth and sun. Such units are nothing but practical units. I hope it is clear. Okay, fine. Right, the next one. 1 light year. 1 light year. This is 1 astronomical unit. Please write down full name. Astronomical unit. 1 angstrom. 1 light year, sir. What is 1 light year? Light year. Light year. Light year, nothing but it is the distance covered by a light with the speed of 3 into 10 raised to 8 meter per second in 1 year is known as light year. ಏನು ಅರ್ಥ ಆಗಿಲ್ಲ? ಅರ್ಥ ಐತೆ? Listen, light year nothing but it is the distance covered by a light. Okay? With how much speed it is moving? 3 into 10 raised to 8 meter per second. In how much time? In 1 year. So in 1 year, with a speed of 3 into 10 raised to 8 meter second, 3 into 10 raised to 8 meter per second with that much speed in this duration, whatever the distance covered by the light, that is take it as 1 light year. So here I will write it is the distance covered by a light with a speed of 3 into 10 raised to 8 meter per second. Distance covered by a light with a speed of 3 into 10 raised to 8 meter per second in 1 year is known as light year. Okay? So how to calculate 1 light year value? In one light year it covers how much distance? You know the formula of speed. Speed is equal to distance by time. Right? Then 1 light year, LY symbol, light year is equal to, this is distance, speed is equal to distance by time. Speed is equal to distance by time. Okay? Speed is equal to distance by time. Then distance is equal to speed into time. I hope it is clear. Right? So speed into time means you will get how much speed is going on? 3 into 10 raised to 8. Speed. Time 1 year. 1 year is equal to 365 days. 365 days. Right? 1 day is equal to 86,400 seconds. 1 day is equal to 86,400 seconds. Sir, maybe you are by hearting this value. No, 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. 24 into 60 into 60, you will get 86,400 seconds. Fix. So if you multiply this with this, okay, you will get nearly 9.46 into 10 raised to 15 meters. Okay, so this is about 1 light year value. In 1 year with this much speed, it covers how much distance? 9.46 into 10 raised to 15 plus 15. After 1 there are 15 zeros. It is very, very big value. Okay? So these are few practical units. So the last practical unit is parsecond. I think it is somewhat, in student point of view, you feel it is difficult, but I will explain in a proper way. Right? Listen carefully. So what is mean by parsecond? Sir, consider sun, earth. Right? Okay. Then the distance between sun and earth is how much? Just now only we discussed. The average distance between sun and earth is how much? 1 astronomical unit. 1 astronomical unit. Right? Then one astronomical unit. Right? Then here it is theta. Okay, this is nothing but parsecond. It is also nothing but parsecond. Okay, this is what the angle between the direction, the angle between these two lines. Okay, that angle, this theta is equal to 1 second arc length. Theta measured in radians, theta measured in minutes, right? 1 minute, 1 second. Right? I think you already studied in trigonometry. Now how to define this parsecond? Actually this is what parsecond. This is what parsecond. When the distance is said to be parsecond, listen carefully. The distance at which the distance from these two at this distance, this angle of subtance, the angle of subtance is equal to, right? How much is equal to an angle of 1 second, arc length of an angle of 1 second. Clear? Still you are not following? Listen carefully. Parsecond nothing but it is the distance. It is the distance at which it is the distance. This is what a distance at which this length of an arc must be one astronomical unit. Right? Length of an arc is equal to 1 astronomical unit. But it subtained how much angle here? That is 1 second. 1 arc second. Then this distance is known as parsecond. Once again I am repeating. Parsecond is nothing but it is the distance. This is the parsecond. When this is parsecond, it is the distance at which this length of an arc must be equal to 1 astronomical unit. Again I will write C. If you consider like this. Okay, it is an arc of a circle. This length of an arc must be equal to 1 astronomical unit. When if this is 1 astronomical unit, this distance is nothing but 1 parsecond. If it is 1 parsecond, this theta must be equal to 1 second. Okay, so the distance at which length of an arc is equal to 1 astronomical unit, which subtends at an angle of 1 second at the center of the circle is known as a parsecond. Okay, so how to calculate parsecond, sir? How to calculate parsecond? You know theta, you know length of an arc is equal to r into theta. Right? Length of an arc is equal to r into theta. R nothing but 1 astronomical unit. Okay? Right? You know already the value. And it is 1 second. Sorry. 1 second. Put 2 times. 1 second. 1 second you have to convert into radians. In next class we will find out the conversions between radian to minutes. How to convert degrees into radians. And radians into 1 minute into how many radians, 1 second is equal to how many radians, we will discuss in next class. So L is equal to r theta, we want L only. This is what 1 parsecond. 1 parsecond is equal to 1 astronomical unit into 1 second. You have to express that 1 second in terms of radians. Then after substitution, right, L is equal to r theta. L is equal to r theta. What do you want actually? This is length. Sorry, this is length. Okay? This is what? Radius of the circle. It is length, this is radius of the circle. Then radius of the circle is equal to L upon theta. L is equal to 1 astronomical unit divided by theta. You have to express this in terms of radians. Then after substituting and dividing, you will get 3.08 into 10 raised to 16 meters. So this is about the value of 1 parsecond. I hope it is clear. So today assignment, sir, define parallax, define 1 light year. 1 astronomical unit is equal to how many centimeters? See, I am not asking meters, how many centimeters? How many centimeters? Clear? So this is about today's class.